Today we are going to be discussing a commercial aviation accident that emphasizes the importance of proper pilot training, crew resource management, and other aviation safety procedures and concepts. Before we begin, check out this footage provided by ABC News back in December of 2013. Asiana 214 was a regularly scheduled passenger flight from South Korea's Incheon International Airport to San Francisco International Airport in California. On July 6, 2013, 4 flight crew members were responsible for safe operation of the flight. There was a total of 3 captains and 1 first officer. One of the captains was actually on a training flight. Captain Lee Kang-uk, 46 years of age, had a total of 9,793 flight hours. However, he only had 43 hours on the Boeing 777. He was transitioning from the Airbus 320 to the Boeing 777, and we will refer to him as the pilot flying. Captain Lee Jong-min, 41 years old, had 12,387 flight hours, including 3,220 on the Boeing 777. We will refer to him as the pilot monitoring, as he was responsible for monitoring the trainee captain. Additionally, there was a relief first officer sitting in the cockpit jump seat. Sitting somewhere in business class, a relief captain was also on board to provide relief to the primary cockpit crew at some point en route of the 10.5-hour-long flight. The aircraft was staffed with 12 flight attendants. There was also a total of 291 passengers on board. Note that the visual is designed to scale. We will come back to this later. The emphasized segment of flight we will focus on is the approach and the crash landing. It is important to note that the day provided visual meteorological conditions, as you can see from the screenshot taken from a video recording of the accident. The skies were absolutely clear. Because of the presence of visual meteorological conditions, San Francisco Approach Control was able to give Asiana 214 a clearance for a visual approach without a working instrument landing system. The pilot monitoring confirmed the clearance and the cockpit crew began their descent. The lack of an instrument landing system, or ILS approach clearance, is an important factor when we discuss accident findings. Looking at this timeline, we see the chain of events that happened in the last 1,000 feet. We should highlight that the Precision Approach Path Indicator lights, or PAPI lights, indicated that the aircraft was too high at 1,000 feet, just 55 seconds before the crash landing. The pilot monitoring recognized this and alerted the pilot flying. They were able to get the aircraft on the appropriate visual glide slope 30 seconds before the crash. However, it seems that the pilots overshot their rapid descent rate, as the PAPI lights indicated that the aircraft was very low 19 seconds before the crash. We are now going to watch a short flight simulator clip. This ghost aircraft shows where the plane should have been, while the solid plane simulates where it actually was.
Asiana 214, Aviation, San Francisco, Star runway clear left, clear land.
clear left, Asiana 214.
The NTSB identified the following as probable causes of the accident: flight crew's mismanagement of the aircraft's descent during the visual approach, the pilot flying's unintended deactivation of automatic airspeed control, the flight crew's inadequate monitoring of airspeed, and the flight crew's delayed execution of a go-around after they became aware that the airplane was below acceptable glide path and airspeed tolerances. We are now going to look at how automation error, mode confusion, automation surprise, circadian fatigue, and pre-resource management played a role in this accident. The plane crashed due to a low airspeed stall. The NTSB identified that the pilot flying had an inaccurate understanding of how the autopilot flight director system and autothrottle interacted to control airspeed, which led to his unintentional deactivation of automatic airspeed control. This is a prime example of mode confusion. Additionally, all of the approaches the pilot flying had previously flown during operational experience were ILS approaches, and there was no requirement to perform visual approaches during operational experience hours. The NTSB found that in the 24 hours before the accident, the pilot flying, the pilot monitoring, and the observer obtained about 5.5 hours, 8 hours, and 10.5 hours of sleep, respectively, as compared to their self-reported sleep needs of about 7.5 hours, 7 hours, and 7.5 hours. Thus, the pilot flying received less sleep than normal in the 24 hours before the accident. Notably, the accident occurred during the pilot's circadian trough, a period about midway through the normal sleep period when a person's psychological state of arousal is normally at its lowest. The human body cannot adapt to transiting 8 time zones in the span of 10 hours. Therefore, all 3 pilots were likely fatigued as a result of circadian disruption. Poor crew resource management was arguably the leading cause of the accident. As a reminder, the trainee captain was the pilot flying, the pilot in command was the pilot monitoring, there was a relief first officer in the jump seat, and there was a relief captain, but he was in the cabin business class at the time of the approach. Upon investigation, the NTSB stated the following findings. The flight crew mismanaged the airplane's vertical profile during the initial approach, which resulted in the airplane being well above the desired glide path when it reached the 5 nautical mile point, and this increased the difficulty of achieving a stabilized approach. The flight crew's mismanagement of the airplane's vertical profile during the initial approach led to a period of increased workload that reduced the pilot monitoring's awareness of the pilot flying's actions around the time of the unintended deactivation of automatic airspeed control. At about 200 feet, one or more of the flight crew members became aware of the low airspeed and low path conditions, but the flight crew did not initiate a go-around until the plane was below 100 feet, at which point the airplane did not have the performance capability to accomplish a go-around. The accident caused complete destruction to the aircraft by the impact and post-crash fire. There was also damage done to the poppy lights and part of runway 28 left. This injury chart shows the number of fatalities and injuries categorized between the flight crew, cabin crew, and passengers. Shockingly, only 3 passengers who were female minors died. It was investigated as to whether one of them died due to being run over by an emergency vehicle or if she was already deceased before that. 49 people were treated for serious injuries, 138 for minor injuries, and miraculously 117 people walked away with no injuries at all. Just to give you a visual of just how many people were on board, recall this image from before. The red shows fatalities, orange shows serious injuries, yellow shows minor injuries, and black shows people who walked away with no injuries at all. The larger figure on the left depicts flight attendants. Note that 3 of the 4 pilots that were injured are not shown in this visual representation. I discussed this accident with commercial pilot student Carlos Berezueta de Felipe. He made the following recommendations to Asiana Airlines. Asiana and other airlines must learn from this accident that pilots should be trained in all types of approaches, not only in using ILS, so that when they encounter a visual approach, they know how to control the aircraft. Also, another important aspect is to have a very deep knowledge of your airplane systems and how they behave in the different scenarios to avoid that type of accident. The lack of CRM between the pilots was one of the main reasons for this accident because neither Captain Kang-guk nor Captain Lee Jung-ming were able to communicate their actions and use the cockpit resources to solve the problem. Asiana Airlines could avoid this and improve their CRM training to pilots by showing them other types of accidents related to lack of CRM. I also wanted to understand his expectations from his future airline employer. I expected my future airline training to be well capacitated in all aspects of aviation, starting from the basic knowledge a pilot must have, the aircraft systems in which I will be flying, CRM, situational awareness, and to be prepared in simulators training in any type of malfunction or problem that may arise. Recommendations to the airlines. I would require more simulation hours on the specified aircraft being used while the pilot is fatigued. For example, have a pilot or captain trainee fly in a Boeing 777 simulator, perhaps after being awake for X many hours after a workout, or figure out some way to pre-fatigue the captain before stepping in the simulator. This will make it so that the first time the pilot is conducting an approach or landing under fatigue, that it is in a simulator as opposed to an airplane loaded with over 200 passengers. This is similar to how athletes of various sports train for competitions. I would decentralize my pilot training from automation reliance to a system of more checks and balances, so that it is not human versus automation, but rather humans with automation. The pilot flying should have been comfortable with visual approaches, and if he was not, he should have let the pilot in command take over controls. To Asiana Airlines, I would further highlight the importance of crew resource management in the cockpit during pilot training. With 3 pilots in the cockpit and high visibility, a visual approach should not have been a problem. To Boeing, I would request that they simplify their 777 computer operations or manuals explaining them, as it was agreed upon by the NTSB that the system was indeed confusing.